choice we make, not something that just happens.
Good morning, everyone, and welcome to the Global AI Bootcamp 2019.
Thanks so much for joining us at over 125 different venues across the globe on December 14th to host these events.
You can predict your customer churn because bad customer experience would drive your customers to switch between providers, especially now where there are options available, there's data about anything that's available out there. So it's very, very important to keep your customers loyal to you, and customer experience is one of the major drivers for that. It's one of the major factors for competitive advantage as well. And enhanced customer experience has been known to translate to increase in revenue. And also, by listening to your customers, you can actually think about what are their problem areas, what are the problems that they're consistently complaining about. By actually listening to them, you can think about how to actually develop your product or the service that you're actually selling to them. And automation, another important thing is you can actually think about use cases where you can automate it. For example, if there is a certain number of calls that are coming into the agent, but the solution from the agent side is a script or like 2 clicks on a business application. So these are the things that you can automate. By listening to your customers and seeing what the agents are doing to solve the problem, you can identify opportunities for automation as well. And intelligent capacity planning. What if your agents are utilized very, very highly in a given span of time in a day, but during some other times of the day they're not utilized fully? How can you efficiently plan your resources so that you can maximize your revenue? So these are different ways by which you can add business value by listening to your customers, and that's the reason why call center analytics is an important problem. Azure Cognitive Services offers many services along these lines. Sorry, go ahead.
Can you make it like the
Sure. Yeah, the thing is, I couldn't move the slides. Yeah. It's not going.
Mouse at the bottom, at the bottom, at the right.
So, Azure Cognitive Services offers many services along all these lines. That's speech to text, sentiment analysis, silence as well, because when you call your call centers, you can see that there's a huge amount of silence where the agent actually performs some actions. There's a lot of silence. How do we treat that? How do we analyze that better? And also translation, when you have, not only in terms of call center analytics, there are use cases where there are different languages where you'd have to bring it down to one common language. So how can we do translation? There's also services for text-to-speech, also intelligent search and keyword extraction. For this session, our important focus would be on speech to text. I want to give you like an overview of what solution we are going to build today. So this will be, if you see the Azure storage or your file system, that's where you'll have your recorded calls with your customer and agent calls. So we want to store the calls in our Azure storage or file system, and then we're going to use Azure Cognitive Services, especially speech to text, so that we'll transcribe our calls to text files. And we're going to make use of batch transcription for this case. I'll explain why. We are going to use batch transcription, and the text files will be written back to, again, the Azure storage file system. This is how it looks, from an overall overview of the solution. For this, there are a variety of samples available. Microsoft has made, Azure Cognitive Services has made available across different languages, and the SDK itself is available in C++, C#, Java, Python, etc. And this link is important. This is where you can find most of the samples of how to use an SDK, how can you develop from there. For the current solution that I'm going to talk about, we are going to use batch transcription. The reason why is that when you think of a call center, there are going to be like thousands and thousands of calls on a daily basis and on a monthly basis as well. So you need to have a system where you can store all your calls in the cloud and do it in a quick manner. So you need to do it in batch-wise and asynchronously so that you can convert thousands of files at the same time. So we are going to use batch transcription for that, which uses file-based REST API. And what are the prerequisites for batch transcription API? We'll need an Azure account, but with a standard subscription. If you want to use it to just test with one sample, you can do it with your free subscription. But if you want to do it on like a bulk of files, you have to have a standard Azure subscription. Right. So this. How my Azure portal currently looks like. I'll take you through each of the services so that you understand how you can set this up yourself. First of all, we need a storage account. So I've created a storage account here. Under the storage account, I've created two containers. One container is for my input recordings. I have a couple of sample files here. I'll talk about that as well. And I've created a separate container for our output where our transcribed audio will go. So you will need, you can even do with one container, but to separate it and make it easy, I have separated it into two containers, but you need a storage account for this. And then this is the most important part where you create a resource. This is a cognitive service resource on Azure. And once you create this resource, I can quickly show you how to create it. You create a resource here, and you see cognitive services. You choose Canada Center, because that's a region, and then a standard one. So this is how you create a resource on Azure.
Can I ask you a quick question?
Yeah, sure.
Does that mean that the data is going to only be resident in Canada?
Yes, and no, and also where, yeah, that is right as well, and where your endpoints are going to be exposed. So when I create this, you see a subscription key and you see an API endpoint key there. So that API key will be only exposed to Canada Central region. So anybody outside that region will not be able to make that call. So it's important that you choose your regions very carefully as well. So I'm just going to skip this because it takes some time, but this is how you create a new resource here. Yeah. And then once you've created the resource group, the resource group is to bring all your resources in one place so that it becomes easier. When you have multiple projects, your number of resources will be higher and will be mixed up. So in order to keep it in one place, you create a resource group. So every time you create a new resource, you can assign a resource group to it. So when you open my call strings for analytics resource group, you can see the resources I've created under it. So I need a cognitive service resource and a storage container. So that's how you create it. And the most important thing here is you can see the subscription key and also the endpoint here. So we will be making use of this subscription key for us to be able to use batch transcription. like I said, so this is another important link. This is where you find all your samples. Yeah. This is the GitHub where Azure Community Services has its SDK samples. For our purpose today, we're only going to make use of our batch transcription sample. Yeah, if you go to batch here, C#. So this is what I'm going to use for today's session. So I've copied this code onto my Visual Studio here. And these are the key things that you would have to know. So if you see here, there's something called a subscription key. I'm so sorry. Subscription key here. That's usually left empty. So once you create your resource, your cognitive service resource, the key that I showed you on Azure, you have to copy that subscription key from there to here. That's the first change you have to do. And you can see the region string there. It has to be important that the region that you copy here matches with the region that you've already created your Azure Cognitive Services with. So you have to make those two changes. And I've made some minimal changes here. This one here, recordings log URI. This is the one that will point to the exact input container that I showed you, which will have all my recordings in the format that we want. That's another change you'll have to make. And another change that you'll have to add here is the storage account. I showed you that we created a storage account under which we created two containers. We have to add the connection string. I'll show you how it looks like. Yeah, if you go to storage account here, go to the access keys. You can see a connection string attached to every storage account. So you need the connection string here to point to the storage account from which we're going to take out all transcriptions. So this is the initial setup that you will need to get started. Go back to the slides now. And the format of the transcription input is also important. In the recent versions, I know that MP3 is also supported, but for now, you have to have your calls in WAV format, and the sample rate should be exactly between 8,000 or 16,000. Anything else would not work. I have checked that. And channels only has to have one channel, so you have to pre-process your audio a bit if anything is different from this. So you have to bring your input to this format. Okay. It's great to have a real call center recording, but it's hard to get data like that. So for today's purposes, I'm going to use a call center call that's publicly available on YouTube. There is a lot of noise even in this call, but I'd still say that this call is more leaning on the ideal side. Because in a real world transaction, we work on a POC like this ourselves. What happens is, there are so many times when the agent and the customer are talking at the same time, and there's so many words that the customer is talking that you cannot pick up, and there's always background noise in a call center, right? There are multiple people solving the same problem for other people, so there's a lot of background noise as well. So it makes it really, really hard to transcribe with great accuracy, but I'm going to choose something which is still noisy, but it's still on the more ideal side. I just want to play this clip for like 5 seconds so that you know what the quality of the audio is.
Help you?
Bought a scarf online for my wife, and it turns out they shipped the wrong color.
Oh, I'm so sorry, sir.
I got it for her birthday, which is tonight, and now I'm not 100% sure what I need to do.
Okay, let me see if I can help you.
Yeah, so this is about 2 minutes long. It's for an e-commerce store where a customer has called in to say that they received the product in the wrong color. And as you can hear it, there's a lot of noise, low quality data because it's recorded in this telephonic conversation, right? So that's the sample I'm going to use to transcribe. So my recording is already there. I go back here, yeah. This is my sample, e-commerce example. The other two are also test samples that I created myself, but I'm going to focus on the output of this file especially. But I want to show you what happens when there are multiple files in this folder. I've made a change in the code where what it does is it's not going to look for something specific. If you have like thousands and thousands of WAV files, it's just going to transcribe everything that's there in this folder. So let me go back here and start it up. And I'll show you how it is. So this is how the output currently looks like. So it will tell you it's started the transcription client, and it will show you all the WAV files that it's trying to transcribe. And each of the transcription will be attached with a unique transcription ID, so that if you want to look into it or track how's the transcription going for each of your files, you can do with that. And it also comes in handy with other things if you want to do intent recognition and things like that separately. We need that ID. So you can see that it will tell you how many are completed and how many are running. It's going to take about 2 or 3 minutes for this to complete. Once this is completed, you can expect the output to be in our transcribed audio. And the current format is that it's going to have a prefix called transcribe, and it's going to have the name of the audio file that we just transcribed and a date timestamp attached to it. That's going to be our file name. Another thing that I want to talk about before the transcription is completed is that when you use a batch transcription API, there are different parameters that you can set. For example, I'm going to show it in the output. The most important feature that we want for call center analytics is diarization. What that means is it's going to separate the two speakers for you. It's not going to tell you, okay, this guy is the agent or the customer, but it will say who is the speaker 1 and who is the speaker 2, and it will keep track of those speakers for the entire transcription. Why is this important? It's very important because you need to be able to separate two speakers and say, okay, if this is the agent, you can separately analyze agent conversations to see how they're doing, are they adhering to their given scripts, and you can look at the customer's behavior to see, okay, are they happy about it, what's the sentiment that they're actually showing. So it becomes very important to separate these two speakers, and we actually have a readily available option to do that. There's also sentiment. Sentiment will be given for each segment. What's a segment? A segment is either 15 seconds of audio. A segment is either 15 seconds of audio, or if there is a silence, the segment ends there and a new segment begins. So in the transcription output, you can actually see for each segment what was the sentiment. Was it positive or negative? Why is segment sentiment important? You can go back and see at what point exactly did the conversation go from negative to positive. What point it came back from negative to positive. So it becomes important for us to see these switches to understand customer behavior and also ways in which we can enhance customer experience.
Question, please.
Yeah, sure.
So is there a parameter that allows you to label which speaker is which consistently if you're going through a large batch so you can run analytics?
Yeah, sure. Right now it will tell you it's either speaker 1 or speaker 2.
No, can you determine that speaker 1 is the call center agent, speaker 2 is the customer?
Yes. Yeah, but you have to build a solution on top of it. The reason why is usually 90% of the time it's the customer, the agent who says, hi, can I help you? But you can say 90% of the time it's right. It's speaker 1 usually.
Right.
But the 10% of the times that could not be that, right? So what we do is we have to build a solution where you pick up on exactly that line. What's the first line that the agent will say, how can I help you?
Right.
You see that that's the standard. If that text is available, then that person becomes my agent, and then you start doing your analytics on top of it. The identification we'll have to build on top of this.
Right, because you need to be consistent.
Yes, yeah, we need to build something on top of it.
Okay, thank you.
Yeah.
I got a question.
Yeah.
So, transcription
is only used to identify the speaker. Can it be used to like filter out the noise in the background?
No, it can't be used to filter out anything. What this essentially does, you'll see the output. So if you listen to the 2 minutes, yeah, I'm gonna just, yeah, this is all done. I'll try. Yeah, if you see here, this is how the output can look like. The transcription, what it does is essentially, whatever it hears, it transcribes it to text for you. Because I'll tell you what, to test this, how this was doing, I did a manual transcription myself. I took about 4.5 to 5 minutes to transcribe an audio for 2 minutes. But this, with more resources and everything, it'll do it in like minutes for you. And you can actually see how good it is. If you see that this is what's going to be displayed, most of the things would be right. Papa scarves, how may I help you? They ship their own color, or sorry sir, got a birthday. If you see that, you'll be surprised how good it is. But we need to see how it's doing. We cannot eyeball it every time when you have thousands of flights. Did I answer your question? Is there any further question?
No, I have no question. How accurate is it generally?
Yeah, I'm going to explain it to you, how we're going to test that. So this is how it's going to look like, and this is the segment results that I'm talking about. So you can see the speaker ID here. So you can see speaker ID 1, it's Papa Scarves, how may I help you? This is usually the case because the agent always speaks first. So you can easily query by speaker 1 data and speaker 2 data to see your agent conversation and your customer conversation. And you can also see that, I think I didn't enable sentiment. Sorry about that. But in the next run, we can actually run sentiment as well, so that for each segment you'll know whether it's positive or negative. So this is how the transcription is going to look like. That's our output. And this is the entire model for the workflow for batch transcription. So how do we see the transcription quality? Coming to your question now. So one of the popular error metrics for transcription is the error rate. How many words were deleted or substituted or new words were inserted? So what this does is you need to have a humanly labeled transcription. So that's the only way to test against something, right? So what I did is I went and transcribed this myself. So you have a ground truth. The ground truth is that I have transcribed it. That's the best possible human transcription. And then it's going to test against the one that we received from the model. And it's going to test with each other. And the error rate is the combination of all the errors that you can see for insertion, substitution, and deletion. But how do I get here? How do I get these numbers? Azure Speech Portal does not have a capability to give it in the generic portal. There is something called as custom speech portal where you can actually go and test this. I'm going to quickly show you that as well. Yeah, this is how the Cognitive Services Speech Studio looks like, and I created a new project there for us to use this. Again, we need a standard subscription for this though. Yeah, so I created a new project called Call Center Analytics. And then I wanted to see how well this is doing. What I did for that is I created my own data set to test it. So this is important. In order to test it, what you have to have is the audio file in WAV format. I just renamed the same file to 1. And then you manually transcribe it. I manually transcribe this. And your first line should be the name of your audio file. And your transcription should start after a tab. That's the format that's required for this text file. So 1.wave is my audio file, and then you have the text associated with it. And if you have multiple audio files, it's the same thing, but each line should have a audio file and the transcription, but separated with a tab, and you can follow the same way for multiple files as well. And what you have to do after that is you have to zip this file. So I have a zip file here, and then I uploaded this here. This is my data. If you can see here, it has audio and transcript. Then I want to test it. I want to see how did the model using the speech portal perform against my own transcription. So I ran a test. So I added a test here, and then it will ask you what are you trying to test. Then it will be against the benchmark model. If you see here, this is the test. The error rate is about 29.64% against my own transcription. So you can see all kinds of errors here. If you don't want to see the deleted words, if you only are interested in insertion and substitution, you can see that. Or if you don't care if the words are deleted, but you only want to see if any extra words were inserted, you can switch you can toggle it here and see the output here. So it depends on different use cases. Sometimes in some use cases, you do not mind if the words are deleted, but you have a high tolerance towards insertion, so you'd be interested to know more about that. So this is how the error rate is going to look like. But in a real world scenario, where it's a real call center, there's a lot of noise available, there's a lot of noise in the background. From the industry standards, from what we've researched, I think an error rate of 15 to 20% would be like really, really good performance. So that's the highest benchmark across all the tests that I could research about. This was the lowest error rate that was achieved, to answer your question on error rate. And so this was our benchmark model. So how do I improve the model that was available off the shelf? Can I do something? Yes, so there's a way of training these models in the custom speech portal. So how does that work? So you're gonna test the quality now. You're like reasonably happy with it. Sorry. Yeah, then here's the switching.
Other people call?
Yeah. Thank you. So I have to come back to Azure again. Thank you. So yeah, so now we've done our first part. We have used the off-the-shelf model and we've evaluated its performance, but we want to train it. So we're going to use the custom speech portal to train our model. So what does training mean? How can we train our model? Think about call centers with specific industry jargons or business applications, for example, in a tech company, where the name of the business applications are very, very different from anything that you've heard. It won't be able to transcribe it properly. Or there's times when the audio quality is bad, but you should be able to guess the name of the company itself that you're calling, right? So the industry-specific jargons and some of the names and everything. Yeah, sure.
Is Azure using any of the training model?
Sorry?
Inside Azure cloud?
Yeah.
Do you have any training model?
Yeah. That's what I've used right now to show you the speech-to-text transcription, right? It's a benchmark model that's out there. That was the model that was used to show you the initial speech-to-text. And you see the error rate is about 29%. But when it's everything, all the speech and the words that you see are actually industry specific. So we can actually train our model using some specific keywords. And I'm going to quickly show how you can do that as well. You can also train the model in another way. You can transcribe some of the data yourself, so that you can tell the model, this is how I actually transcribe it. You can learn from it and transcribe better. So two different ways of doing it. For simplicity purpose, today I'm going to show you how you can just use a text document with related text and train the model with that and see if the model performance actually changes. What I've done is, just by listening to the conversation once or twice, in the conversation, the agent talks about a location of their shop in Hunter Mall, where she thinks there is good stock of what the customer is actually looking for. So that's like a location of the store. And then we also have the name of the company itself, that's Parker Scarves. And I was surprised that the model could not pick up bot, because that's one of the major things that someone talks about. I bought something from you, this is not what it was, it's not matching, it was not able to catch that. And then scarf and also zip code. So I wanted to ship to some place. What's your zip code? It was not able to catch zip code. So just out of intuition, I added these 5 words in a text file, and I went ahead and trained the custom model that's available with this text file. So it's a standalone text file. You can actually do, right over here. I just uploaded here the document. It's called e-commerce related text. And after I did that, I trained the model. The training actually takes some time. It takes about 15 minutes, 10 to 15 minutes for you to train a model using your document. I did that. And what I did is, when I tested, I gave my manually transcribed data, and then I tested how did the off-the-shelf model perform versus how did it perform with the model that I actually trained, right? So there are 2 models. If you can see here, it's called description, it's testing benchmark versus model trained with related text. I called that trained model e-commerce model, and the second one is B3.3 unified. It's the off-the-shelf model that's currently available in Azure. If you see here, by just adding that, I was able to improve the performance. The error rate of the trained model is about 26%, 26.35, whereas the other one is about 29.35%. And this is just an example, but ourselves in our own company, when we worked on a POC with like lots of calls, when we just trained with some of the keywords, there was actually a good jump in accuracy. We've seen that actually work. So training is fairly easy. You just need either you give a transcription or a text. It's using on the custom speech model, and you can actually see how you can improve your model performance. Yeah, so this is, I want to, show some, this is an important thing, because the first time that I used this for testing and training, I had issues with it. The reason why is because you need to have your audio and your text in a very specific format. For example, so this is the recommended quantity for testing. So this is only for demo purposes, what I showed you, but when you're using it in an industry context, this is important. You have to have 5+ audio files, and if you're testing with audio plus human label transcripts, you at least have to have half an hour or 5 hours of audio. So this is what's recommended, and related text. And there were challenges because your WAV file or MP3 file has to conform to the standards, of what is actually set here. So that's important. And even the text file. So when you save your text file in Notepad, there's something called as byte order marking. So sometimes it doesn't save with it. If it doesn't have byte order marking, Azure does not take it. So you have to ensure that your encoding is set with byte order marking for you to use a related text. So if something is failing, the error messages are not that clear on Azure right now, so I would recommend, if you're using it and you're seeing some issues, ensure that your data is in the exact same format. Read about, there's a good link about data preparation for custom model training that will give you a good idea about how to prepare your data. All that said, I want to give like a quick, not even an overview. What can we actually do now that you've transcribed your text, thousands and thousands of calls? You have text files that you can finally work with. So there's an entire text analytics API layer that you can build on top of it, so that you can analyze sentiment, you can understand language and entity recognition as well. That's a very important thing because it will help you extract key phrases from your conversations. If there are thousands of calls, what are the customers really talking about? So you can go and see your entities, what are your key phrases, etc. I don't have a demo here, but I want to show you how well it works. So this is the example. You know, if you see here, I had a wonderful trip to Seattle last week. If you have the text analytics API, it can tell you the key phrases here: week, space needed, wonderful trip, Seattle, and times. So think about, you know, actually using this on the data that you've just collected. What are the key phrases? If someone's always complaining of a particular business application, you know that that's your key problem area. And that will give you an idea about how to focus on specific issues and increasing customer experience. The last thing that I want to talk about is, okay, this is a possible dashboard that you can actually build putting all of this together. For example, you can think about how many calls per hour were filtered by results. Were there any calls indicating lawsuit? You know, it could say, I'm going to sue you, or I'm going to take you to court. You can search using these phrases to see how many actually have the risk of going to court, and average time of service, and is the agent actually adhering to the scripts that were given to them? So this will help measure quality of your agents, and reasons for canceling contract, etc. So you can build like a dashboard, so you can explain to your business stakeholders about how you can drive revenue, how you can reduce customer attrition and customer churn, and you can explain your insights and prove that call center analytics can actually drive business value. I think that's all I have today. Is there any questions before I end? Yeah, please.
So before you mentioned that you have recommended metrics to train your models.
Yeah.
You're not the only person looking to use this service for your business. So other people will want to train their data as well.
Right.
Are you able, does Azure make it like their training data available to you? Or is it possible to get other people's training models?
Yeah, so if you see, like, you see the versioning of the model, v3.3, so at every release that Azure puts out of its model, they do take into consideration of all the custom training that goes in, but they decide what training data is useful or not before they actually put that model to be used by general public. But that's the whole point of it. That's how the community actually adds the quality of the model.
But the main line there is that you are not going to take advantage of other clients' improvements. It's going to be general speech recognition improvements, but not other ones, because some business versus other business with other clients. We've got a couple of other questions.
What about the personally identifiable information and PCI type, credit card information? Is it able to filter that out before it gets transcribed, or stop it from being transcribed?
No, it won't be able to do that for now. It has security, like in the way it actually does the transcription within the region and everything. It has all the rules and everything in place, but the data is what you feed it to.
So it's not be able to recognize that that's a pattern that looks like a credit card?
No, but you'll have to tell it the same
Yeah,
thing.
you can do that later if you want with another tool like Lewis, language understanding, to understand this. And if you don't want, because the scenario that we face is that a lot of clients say, okay, that's amazing, but I don't want you storing, as Microsoft storing this voice recording with this data in the cloud with this critical information. So what you can do with this service and other services is run this service in your networking containers. So you can download, not all of them are available, they are going to be in the future, but you can download these services to run in your network. So you're going to send your audio in your network to a container, it's going to analyze it there and give you the back, and it's never going to leave your data security network. But this container needs to be connected to Microsoft, because the container is using Microsoft AI, and from time to time it's going to say Microsoft, hey, bill Meghana $1,000, hey, bill Meghana $1,000, because it's sending billing information. But the info will keep in your network. So you can detect this information, you can detect these kind of things, and you can even filter this to not leave your data center.
Yes, please.
You mentioned like in training you need like thousands of hours of audio and possible multiple text files. So it probably will take a lot of compute power. So I'm not sure what is the pricing yet. So I see that probably speech is quite expensive, expensive service. Can you use like cheaper something like Azure Watch? So I create multiple watch jobs to be efficient, and should we have Azure Watch doing faster and cheaper?
No, but the training will still happen on the custom speech portal. You know, you might store it elsewhere, but the training will only happen on this custom speech portal.
So you don't isolate it as a kind of
No, because it all depends on, no matter what you do, it all depends on the number of seconds of audio that you're actually using to train the model. If you go and see on the pricing calculator, that's what it is. How many seconds of audio is it processing? How many seconds of audio are you using to train it? You can train it, but then if you're using every time you actually train using custom speech portal, you'll be billed based on the number of seconds of audio. Yes.
One question, in regards to the different version of a different model that may come out, do you have to retrain it again, or is it?
It's available. So actually v3.3 and v4 of two Microsoft off-the-shelf model, it's available for you to actually test and see. Sometimes the older versions might actually work for you, better for you, so you can actually compare off-the-shelf models as well.
But if you want to take advantage of the newer model, with all of your data that you have, like you have lots of data, you have to retrain it again?
No. The newer model that's available off the shelf, it's readily available. You pick and choose, but
use your original data that it collected.
yeah, and then if you want to train using the specific data set that you wanted to train, you train on top of the already available model, and then you have a new model with your trained data.
How many of you know this one? Mozilla project. So, because voice is kind of a tricky, face was tricky, now voice is going to be tricky because deepfakes and these kind of things. So Mozilla started to create an open source project which is called the Custom Common Voice project, where you can donate your voice to improve the speech recognition system. So here you can do two things. You can speak and donate your voice, so you can improve the process, or you can listen to samples to see how it's going to do. And this is completely, as far as I understand, I may be wrong here, open source. So you can get here and see who is the voices, which are the voices that I've been using, which are the person to donate this, and yada yada yada. So there is a lot of movement around these kind of things, so we can understand how it works. Because as you asked, there's a new version. Can I take advantage of that? Yes. But do you really want to take advantage? Because this version has trained with a different set of voices. So maybe the improvement are for language, for Spanish language, or for English. So there is a lot of things happening in the voice world to try to see what's happening. And by the way, I'm going to do this very fast. This is the second part of this one.
A huge thanks to all the organizers who made this event possible. So organizers, please get up, and attendees give them a big round of applause.